So let's see how to solve the uh, how to find the candidate keys of the we have been given a relation a b c d e f. So सबसे पहले हम एक इसी का क्लोजर फाइंड कर लेते हैं ए बी सी डी ई एंड एफ। इसका हमें क्लोजर पता है कि इसका अगर हम क्लोजर निकालेंगे तो बाय रिफ्लेक्सिविटी प्रॉपर्टी इसका क्लोजर ए बी सी डी ई एंड एफ ही आने वाला है। अभी हम फंक्शनल डिपेंडेंसी की मदद से अब हम इन एट्रीब्यूट्स को डिस्कार्ड करेंगे। एज यू कैन सी कि विद द हेल्प ऑफ ए बी वी कैन डिटरमाइन सी, सो वी डोंट नीड सी एनी मोर, सो वी कैन डिस्कार्ड इट। विथ सी I can determine DE. So since AB determining C and C determining DE, so with the help of transitivity property, we can discard D and E as well. And since E determines F, we can also discard F. So now we have AB, and अगर अब इसका हम क्लोजर निकालें, so इसका क्लोजर with AB we can determine AB, and with AB we can determine C, with C we can determine DE, and with E we can determine F. So as you can see, uh, the closure of AB is A, B, C, D, E, F. So it can determine all the attributes of the relation. So therefore, it's a super key. AB is a super key, but is it a candidate key? We have to first find out. So let's first find the closure of A. So if we find the closure of A, as we can see with A, we cannot determine anything. We can determine it A and B together, we can determine C, but A alone cannot determine C. So the A closure is A only. So it is not a super key. Let's find closure of B. B we can with B we cannot determine anything, so B is also not a super key. Therefore, A and B is a candidate key. Let's all and A and B is also a prime attribute. A and B. Now, since we have got our first candidate key, so let's see if any of the prime attribute is present on the right hand side of the functional dependency. As we can see, A is present on the right hand side, so we can replace A with D. So let's replace A with D. So let me make some space. So let's replace A with D. The at the closure of DB will be DB, and with with D we can determine A, and we can with since we have AB we can determine all of the other attributes. So let's see if D alone can determine anything, because we know that candidate key is the minimal super key. So D, as we can see, with D we can determine D, of course. We can also determine A. With A we cannot determine anything. So D is not a super key. Therefore DB is also a candidate key. D is also a prime attribute. Now we have replaced A with D. Now let's try to replace B with C. A, C. So we can see with AC we can determine AC, and with C we can determine B, and since we have A and B we can determine all the other attributes. Let's see if C is a super key or not. With C we can determine C, With C, we can also determine B. With B, we can determine C. We can also determine D and E. D and E. With D, we can determine A, and with AB, we can determine C, and with E, we can determine F using this functional dependency. So as we can see, C is a super key. Therefore, this AC is not a candidate key because it is not a minimal super key. Minimal super key is C. Therefore, C is also a candidate key and it's also a prime attribute. Let's see if these prime attributes are present on the right hand side of the functional dependency. We have already replaced A and B. Let's see if D is present on the right hand side. Yes, we can see D is present on the right hand side. We can decompose this like this. C, we can determine D and C determines E. So with D, we can replace C. This DB can be replaced with CB. So as we have already find out the closure of C, and since C is a super key, this whole set cannot be candidate key. Therefore, CB is not a candidate key. Let's see if D is, since D is not present, C is also not present. C is present here, as you can see, but C can be replaced with AB, and AB is all we have already written, so no need to write it again. So here we have solved our question. The candidate key we have find is AB, DB, and C, and the prime attributes are AB, DC.